Very good morning, children. Welcome to the next session of online class, 10th class Physical Science. We have been discussing the first chapter, that is reflection of light at curved surfaces. Already we have discussed in the previous classes about concave mirror and convex mirror and how to find out the normal for these types of mirrors. And one more important thing is we need to draw the ray diagrams when the object is put in front of the concave mirror. So in order to draw a perfect ray diagram, we need to understand some fundamental principles for drawing the ray diagrams. So our today's topic is fundamental principles for drawing the ray diagrams. See children, fundamental principles for drawing ray diagrams. Here I have shown you some diagrams. According to the rules, we can measure the position of image of an object when put in front of a concave mirror experimentally. Let's learn a method to draw the ray diagrams to find the image for an object placed in front of the concave mirror at various places. In this particular picture, I have shown you a candle, that is an object. Candle is placed in front of the concave mirror, and then assume a candle is placed in front of a concave mirror on its principal axis. The horizontal line here represents the principal axis. Here, observe the two light rays in the figure started from the tip of the flame, and the reflected rays of these two rays meet at a point A. See children, you can clearly observe here. I have drawn two incident rays from the tip of the candle flame which are coming, and when touch the reflecting surface of the concave mirror, they will reflect, and their reflected rays are meeting at the point A. Drawing reflected ray for a light ray incident on a concave mirror is not so easy, children. So drawing normal line at the point of incidence and reflected ray with the angle equal to the angle of incidence is too long process, and it is a time taking process. For this, we have an alternate and easy method. We have seen that all light rays that are parallel to principal axis get reflected such that they pass through the focal point of the mirror. So for drawing any diagram, the most suitable ray to draw will be the one that comes from the object and goes parallel to the axis of the mirror. The reflected ray will be the line drawn from the point of incidence on the mirror and passing through the focal point of the mirror. Consider this ray as R1. Okay, here I have shown you the ray 1, the incident ray 1, that is R1. So from where this R1 is coming, you can clearly observe the children here, rule 1. So the R1 is coming from the tip of the flame, and this incident ray R1 is going parallel to the principal axis. As you all know that this horizontal ray, this horizontal line indicates the principal axis, and this is the R1 which is parallel to the principal axis. When the incident ray is parallel to the principal axis, the corresponding reflected ray will be always passes through the focal point, that is capital F, on the principal axis. So this is the rule number 1. We have to remember this. So once again I will repeat children. When the incident ray coming from the object is going parallel to the principal axis, then the reflected ray of that incident ray will always passes through the focus. Okay. The converse situation of a previous one is also true. That is, a ray that passes through the focal point of the mirror. See here in rule 2, we can clearly observe that R2, that is the second incident ray, which is again coming from the tip of the object, that is tip of the candle flame, and that second incident ray is passing through the focal point of the mirror, and it will travel parallel to the principal axis after reflection. Okay, this R2, upon incidenting the surface of the concave mirror, reflecting surface, after reflection, it goes parallel to the principal axis. Its reflected ray goes parallel to the principal axis. Okay, this gives our second ray R2. This is the rule number 2, and we have to remember this also. Once again, I am going to repeat. The incident ray, when passes through the focal point on the principal axis, that corresponding reflected ray will be passing parallel to the principal axis. Okay children, this clearly I have shown you in this second diagram. And now we have seen earlier that any ray that is normal to the surface on reflection will travel along the same path but in the opposite direction. Okay, that means when the light ray, the incident light ray coming from the top of the object or any part of the object, no problem. When the incident ray is coming along the center of the curvature, then the reflected ray of that particular incident ray also passes in the same line That means in the same line but in the opposite direction. Why it is passing through the same line, children? Because this R3, the incident ray number 3 is passing through the center of curvature. The center of curvature, nothing but here the normal, it can be said as normal, because the line which is connecting one point on the mirror surface to the center of curvature is said to be the normal for that mirror. So when the light ray is incidenting along the normal, then the reflected ray of that particular incident ray will also be going after reflection, it will be going in the same line but in the opposite direction. So I have shown you here two arrow marks, one in that direction and another in this direction. In this direction it indicates the incident ray, and this arrow indicates that is the reflected ray, and both of them should be shown on the one particular line only. We know that a line drawn from the center of the curvature to the mirror is always perpendicular to the tangent at the point where the line meets the curve. So if you draw a ray coming from the tip of the object going through the center of curvature to meet the mirror, it will get reflected along the same line. So we have to consider this as R3. Okay, R1, R2, R3 are easy and basic rules for drawing the images. Okay. So when an object is placed in front of the spherical mirror, any two of the above three rays, that means R1 or R2 or R3. Okay, any of the two rays from these three rays can be used to detect the position of the image. Okay, children, that means in order to identify the correct position of the image, we need to draw any two rays. Maybe R1 and R2 or R2 and R3 or R1 and R3. Any two incident rays we have to draw, and then reflected rays also should be drawn, so that the point where the reflected rays meet will gives a clue to draw the image of the object. Okay, the meeting point of these rays gives the position of the image of an object. Okay children, now see this last and final diagram very carefully. As shown in the figure, intersecting point of light rays coming from the top of the flame and intersecting point of the light rays reflecting from the bottom of the flame are equidistant from the mirror. Therefore, as shown in the figure, image is perpendicular to the principal axis, and in this case the image is inverted. See children, here I have shown you, in this particular diagram, I have shown you the two incident rays which are coming from the tip of the object. Okay, R1 and R2. I have indicated with the red color, R1, R2. These are the two incident rays coming from the tip of the object. Okay, if we need to draw the complete picture of the image, we need to draw the incident rays which are coming from the bottom of the object also. So I have shown you the two incident rays R1 and R2 with blue color. These two R1 and R2 are the incident rays which are coming from the bottom of the object. Okay, that means here 4 rays I have shown you, because I need to draw the top part of the image as well as the bottom part of the image. Hence, from the top position of the object, I have drawn 2 rays, incident rays R1 and R2, which are shown with red color. And from the bottom of the object also I have shown you 2 incident rays, that is R1 and R2, with blue color. Okay. Then coming to these 2 incident rays, R1 and R2, as they are passing, R1 is passing parallel to the principal axis, so that after reflection, its reflected ray will be passing through the focal point. Okay, according to the rule number 1. Then the second incident ray, that is R2, is incidenting, it is through the focal point of the mirror, so its reflected ray is passing parallel to the principal axis, according to the rule number 2. Then the two reflected rays of R1 and R2 are meeting at the point A. So here exactly we will get the image. Which image, children? Since the R1 and R2 are coming from the tip of the object, and these reflected rays are meeting at this point, and at this point we also will get the image of the tip of the object only. From where these incident rays are actually coming from? Tip of the object. Hence, in the image also we have to show the tip of the object only at the point of A. Okay, this point A. Next, I have represented 2 rays, 2 incident rays which are coming from the bottom of the object, that is R1 and R2 with blue color, and here R1 is passing parallel to the principal axis, so that its reflected ray is going through the focal point according to the rule number 1. Now R2 I have shown you here. This R2 is incidenting through the focal point of the mirror, hence its reflected ray is passing parallel to the principal axis. Okay, according to the rule 2. So again I have considered the rule 1 and rule 2, and I have drawn the 2 incident rays and the corresponding reflected rays. So the reflected rays of this R1 and R2 are meeting at this point B. Okay, hence again here also we will get the image. Which image we will get here? Because Since the R1 and R2 are the incident rays which are coming from the bottom of the object, here at point B also we will get the image of the bottom of the object only. So here only we need to draw the bottom of the object and here top of the object. In this way we will draw the image, and as we draw the image in this way, here we get the inverted image. Okay, this is the real image, this is the object. Okay, and this is the image which is perpendicular to the principal axis and also the inverted image. Why we need to draw the like this also I have explained clearly. Okay, I hope you have understood. So this image is the inverted image in this case, because we have to consider the incident rays actually from where they are coming from. The incident rays which are coming from the tip of the object, their reflected rays when meet at a point A, we will get the image of the tip of the object only. And if the incident rays coming from the bottom of the object, then after reflection where they meet, at that point we will get the bottom of the image of the bottom of the object only. So that's why we need to draw the reverse image like this, inverted image. We call this as inverted image. Okay children, so these are the fundamental principles to be remembered by everyone, which are very very important. And whenever we are drawing the ray diagrams for concave mirror, so we have to keep in mind that rule 1, rule 2 and rule 3. Okay, if we remember all these 3 rules, okay, then we can easily draw the ray diagrams for any object wherever the object is placed in front of the concave mirror. Okay children, so try to practice how to draw the ray diagrams for an object placed in front of the concave mirror, and we'll meet in the next class. Thank you children.